Hi everyone, welcome to today's webinar. And today we are going to talk about three topics: UC HA and UC maintenance and UC troubleshooting. So let's move to the first topic, UC HA. This topic is mainly talking about the high availability HA features of the UC. By the end of this session, you will have a comprehensive understanding of UCHA's working principles and practical operation methods. In this course, we will focus on becoming familiar with the HA features, the HA configuration process, and the master standby switchover mechanism. We will go through how HA works and how to set it up correctly and how to perform and verify fail-hour operations in practical scenario. So first, let's address the core questions. What exactly is HA? HA stands for High Availability Active Standby. In essence, an HA solution leverages the collaborative operation of two devices to ensure uninterrupted system operation even in the event of a single-point failure. This mechanism is crucial for enhancing system reliability and reducing service downtime. And next, we will analyze the working logic of UCHA by combining this schematic diagram. As you can see, the architecture includes two UC devices, each assigned a private IP address, and they share a unified floating IP address. The devices maintain communications through the heartbeat detection. So under the normal circumstance, device A operates in the active state. The two devices mutually monitor each other's running status through their representative management ports. And when device A experiences a failure, device B will not receive a heartbeat response from device A. At this point, device B will automatically switch to the active stage, activate its service port, and take over all business service to ensure service continuity. And after device A recovers, the two devices will redetermine their active standby roles according to the pre-configured priority policy. And next, we will focus on the second part, the UCHA configuration. So now we enter chapter 2, the UCHA configuration. And this chapter is divided into three parts: the basic condition for UC and the configuration and some expand configuration. So first, we need to clarify the basic practicals for deploying UCHA, which includes four core requirements. The first is prepare two UC devices of the same model, such as the UC350 Pro. And the second is ensure the software versions of the two devices are completely consistent. And the third is collect the license information of both devices, including device SN and hardware ID, and submit it to the technical support team. To us, we will generate a new license and upgrade the UC with a new license to support HA. And the deployment environment must have multiple network segments, and independent network segments should be allocated to the management ports of the two UC devices to ensure stable heartbeat detection between them. So in a HA deployment, there is an important prerequisite. Both UC devices must be the same module and run the same firmware version. Hardware and software consistency on both nodes is required to ensure the HA system can be configured successfully and operate reliably. So we can see from the two pictures, the device module are the same, the UC350 Pro, and the firmware version are also the same. Okay, in addition, HA requires proper authorization to be enabled. It is not supported by default. So you must first obtain and activate the HI license or permission on the device before you can configure and use the HA filter. And from the picture, we can see in the maintenance the license, which is HA is also called hot standby, and we can see is authorized. And we also can see from the on this device, HA has already been authorized. As you can see from the status show here, the HA filters is enabled and licensed. So it's ready to be used for configuration and deployment. And the final prerequisite involves network configuration. So we need to modify the management port IP of UC of two UC devices, ensure that UCA and UCB are configured with different management IPs and are connected to the same switch. This configuration is essential for ensuring smooth and reliable heartbeat detection between the two devices. So yes, we can check in the systems and networks. Okay, next in the HA configuration sections, under the HA system settings, we need to configure the local management port and the peer management port, also called remote management port IP. And at the same time, we must enter the peer remote device serial number. You can find the serial number on the device homepage, right, in the system information section. So we can just check the SN in here. So we can check the SN in the device page. And after the basic HA settings are complete, we also need to configure a floating IP address. This floating IP is used for service communication in most cases. SIP signaling and call connections are established using this floating IP rather than the individual device IP address. And we also can see In the systems and the hold standby, I already fill in these parameters. Include the local management port IP. This need to fill in, and the remote. We just fill in the some local management port IP and remote device asset, and some are defaults. We don't need to change it. And we also set the floating IP management. We set the floating IP here, and we can also edit it. And after the configuration is complete, we can check the HA status through the management interface. In the system information page, you can view whether the device is currently operating at the active node or the standby node, as well as the overall HA role and status. And we can see in the service status, and this is active device. Like this is active device. And the other one is standby status. And in addition, we can also config, sorry. And in addition, we can also config interface monitoring and switch hour rules. These settings including interface monitoring, the network port detection, switch hour rules, and floating IP. Floating IP are optional and not strictly required, but they are recommended. These are recommended for more refined HA behavior. And the purpose of interface monitoring is to improve the accuracy of the switchover decision. The system monitors the status of selected network interface and applies the switchover rules based on their assigned priority or weights. And when a monitor interface fails or its status drops below the defined threshold, the HA system can trigger a rule switchover according to the config's waiting policy. And let's refer to the course outline again. And we need to have complete the configuration section. We will now proceed to the third module, active and standby switching. This module will explain the triggering conditions and execution logic of active standby switching. A switchover may occur if the device powers off, restarts, and or lost the network connectivity. In these cases, the HA system will automatically trigger a role switch. And the network port detection, it means the interface monitoring switchover rule is mainly based on weight calculation. If a device network port is unplugged or become loose, its interface weight will drop to 0. And the system then compares the total weights of both nodes. And if the difference is greater than or equal to 10, the switchover will be triggered. So this is a process of active and standby. And then we will examine the switching logic under multiple network port detection scenario, where the total weight difference determines the switching behavior. Like the first pictures, if each service network is configured with a weight of 10, a failure of any single service network port on the active UC will immediately trigger active standby switching. And if two service network ports are each configured with a weight of 5, a single port failure will result in a weight difference of only 5 and no switching will occur. Only when both ports fail will the total weight difference reach bigger than 10, triggering the switch. So by extensions, active standby switching will only be triggered when the total weight difference between the two UC's networks is bigger than 10. And let me show you the demo. We can set the in the host standby, we can set the network port detections here. Like I set the G3. And we can I can also set its weight. And the weight is bigger than 10. So the net port is filled, the active and standby switching will occur. But this is optional, so it's just we cannot do this. Okay, that includes today's professional training on UCHA topic. If you require further technical support or have any questions, please contact us. And let's move to the next topic. The UC routine maintenance. The training will focus on three core aspects of UC routine maintenance. The first is how to check if the UC devices is running in a normal state, and the usage scenarios and content of different types of UC logs. The third is common problem location methods for daily maintenance. So mastering these skills will help you handle most UC operation issues effectively. Outline. The training is divided into 3 modules. The first is a status check, covering device, service, slot, license, including will introduce operation logs, service logs, and config changes, and D-Link logs. And the last is FAQ. We will focusing on the troubleshooting, extension, registration, and core failure issues. So first, let's look at the status page. Here we can see key metrics such as the CPU usage and the local storage usage, and also the current numbers of active cores. So all of this information can be viewed directly from the device interface. And when we came across high CPU usage issues, you can troubleshoot through these steps. So first, you check the current number of calls to see if it exceeds the device load capacity. We just can check the current call on here, and we can also check in on the CDR, the current call, the details of about the current call. And the second is verify if all in use the extensions have recording configurations enabled, just like recording and consume a lot of CPU resource. And we will talk about the recording configurations later, detailedly. And the third is check the CDR records to see if there is active transcoding behavior during calls. Did you know the transcoding? Since we all know the codec, right? And when the caller side has a different codec with the caller side, the UC needs transcoding in that time. And the fourth is look at the SIP stack page to check if the incoming call statics have increased significantly. And we can check it in here. We can see the F and the T. The F stands for the fault, the fault calls, and the T stands for the total. The total calls calling from the SIP trunk. And it also can be checked in the SIP stack in here. Okay, the last is download the logs. Download the system snapshot, service log. Next is high memory usage troubleshooting. There are two main steps. And the first is check if all currently used extensions have recording configurations enabled, as coding can take up large memory space. And the second is download the service log. You can monitor the real-time memory usage through the device usage dashboard on the screen also. So now let's address high local storage usage issues. And the troubleshooting methods are as follows. First, we can check it in the disk manage to check the usage of various types of data. Like this. We can check it in the system storage to check the local data disk in here. And the second is the usage 8000. We can look in the system and use the df command to check the overall hard driver usage. As we all know that the UC 8000 is a software-based platform, right? And this helps you identify which stage is taking up the most storage space. And let's move to the service status. Is we can just check it in about on the service states. You can view it directly on the home page, right? It shows the running status of key service such as SIP, SIP, and HA and NMS. And we can check it here, the SIP stacks, whether it works, and the HA, whether it is configured and running. And we can see here, it's not configured, and we checked before. We can have the state of the HA, right? And also the NMS. And as mentioned earlier, NMS is used to connect to the network management platform. And if any service shows an abnormal status, we can go to the maintenance section to check and troubleshoot the issue. And then the slot status. We can also check the slot status. Through the slot view, we can see the current status of each of the 4 user boards. So for example, for the DTU, the E1 user board, a red status usually means it has been configured, but the peer sites may not be connected properly. And for an FHIS use board, a blue status indicates it has been configured and is working normally, while gray means it has not been configured yet. And for FHIO boards, a green status indicates that the port has been configured and is active. And we can also check the device information and the license status. This includes details such as the okay, let's check in this page. It will be more details. We can check the device information here. And this includes details such as the firmware version and the system update time. So in support and the training scenarios, we often ask for this device information. This version number is especially important because it tells us exactly which software release the device is running. And the uptime helps us determine whether the device has recently restarted and how long it has been running, which is useful for evaluating overall system stability. And in addition, the license information shows the authority's capacity and filters. For example, how many extensions are licensed, and some customer may receive the device without activating the license, which can cause filters to be unavailable. So by tracking the license informations, we can determine whether the required license have been purchased and activated, or whether the issue is caused by something else. And finally, let's talk about the unreeled event logs. These logs are divided into 4 categories. The system logs, including events like operate success, failure, high CPU usage, and license expiration. And the second is the call service logs, covering critical events like call service crash, SIP trunk status change, and HA heartbeat timeout, etc. And the last is operation logs, including events like fail ban, triggers, and users login success or failure, password change. So checking these logs regularly helps you detect potential issues early. Okay, let's move on to the second module, the view log. So first, let's look at the logs. The operation logs records web activities. For example, which user accessed which page and at what time. From here, we can review actions such as administrators opening the status page, a configuration page, or quick setup, and use this information for troubleshooting So just let me show you a demo. For example, when we check the so just wait. So just like we open the CDR page, and it will be showed in this log. We just check the CDR, right? And about the time and also the IP and also the username, the account, right? So this function is very useful for tracing access history and auditing administrative operations. And then the service log. The service running logs are mainly exported for the RZ team. These logs record internal details such as CPU activity and the SIP call message and other abnormal or low-level system events. This function is primarily used for deep troubleshooting, and it's enough for everyone to know that this export option is available and when advanced analysis is required. And the config change log. The configuration change log records all parameters and configuration modification. This is very useful when troubleshooting change-related issues, and sometimes users report that a setting was changed unexpectedly, and no one admits making the change. In such cases, the change log gives us a clear audit trail. And from this log, we can see exactly which accounts made the change, what was modified, and at what time. So, for example, it may show someone just have the manipulation or just set the edit the root. And with this code, we can quickly verify who performs the operation and trace the source of the change. And the last is the link log. The DINLink log are used for integration with the DINLink soft phone. They collect abnormal and diagnostic logs generated by the soft phone client. These logs can be uploaded and then downloaded from the UC site for further analysis by the RD team. We will cover this part in more detail later than we discuss. And let's move to the last module of this course, FAQ. This part will solve two of the most common problems in daily maintenance. The first is the extension registration field. And when we just have the extension register field, we first need to check the PBX globe settings, the SIP stacks. You also need to check the IP and the port is whether correct. And the second is the extension, check the SIP profile. We can check it in here. The profile is G-link default, G0. And the third, we can check the extension registration history. And the last is go to the system, to the security, and to check if the terminal IP is blocked. And we will talk about it detailedly in the after. And the last is the call field. There are two call steps. When we meet a call field, we also can check the CDRs. The CDRs shows many failures and the reason why it fails. You can see that in this picture. The caller side just responds the busy, so made the call failed. And we can also check it in here. We can stop the call trace and reproduce the issue. And once the reproduction is complete, and we can click to the stop to download the call logs from this period. Okay, that's all for today's UC routine maintenance training. And if you have any further questions or need technical support, please contact us. Okay, let's move to the last topic of the UC troubleshooting. And this training will focus on three core aspects of UC troubleshooting. The first is the solution for core voices related issues and troubleshooting guides for calling problems and fix for registration failure scenarios. And we just mentioned these two types issue in last PPT, right? So mastering these skills will help you handle most UC operation issues effectively. So let's just start with chapter 1, the solution to registration failure. And we all know that there are two types of the registration in our UC, right? The SIP extension registration field and the IMS account registration field, which is a way of the SIP trunk registration. So for registration issues, we can directly check the extension status page to see the registry state of extension. If an extension shows registry failure, it should verify whether it has been taken over by another devices or duplicate registration, or whether there are other configuration or network-related causes. So on the extension status page, we can see the which extension, like the 6001, are registered, and the registration source, and the registration IP address, and also the registration expire time. These details help us quickly understand the current registration condition. And if an extension fails to register, we usually check several common causes. The first is whether the password is correct. We can try resetting and re-entering the password to make sure the credentials match on both the terminal and the server. And next, verifying the correct SIP interface or listening port is selected on the devices. Another possible reason is registration conflict. Since the server may allow only one active registration per extension, if this extension is already registered by another user or device, multiple terminals competing to register can cause failures. In that case, we should also verify whether the registering IP address matches the expected device. So, for example, here we have extension 6006. And we can check it in here, the register source and the status, the expires times, and the agent. We use the IBM branch. So let me change the password and to see what it will be like. And we can see it shows the unregistered, right? And we can check here the SIP register info about it. So when we first count the unregistered, we just first we need to change the password to the right password. Okay. And we also sometimes we need to check the registration concurrency settings, like the 6006. We can change the mass concurrent register. And if multiple devices are trying to register with the same extension, so we need to change the master concurrent register. And if your scenario requires multiple devices to use the same extension, so you need to increase the allowed registration count for that extensions to prevent it from being taken over by another device. And we can also use tools like the pin test for troubleshooting. For example, if we need to check extensions, a device or a SIP server, we can run a pin test to verify whether the network is reachable. We can also perform a trace route to see at which network hop the connection may be failing. This is a pin test. And we also have the trace route. These tools are very helpful for administrators when performing network diagnostics. And another thing we should check is the failband list. This mechanism limits registration intervals and registration frequency. If a device sends registration requests too frequently or repeatedly fails authentication, its IP address may be automatically blocked. In that case, the extension will not be able to register until the IP is removed from the block list or the block expires. It will be released in a shorter period of time, but in sometimes it not will be released. So for example, in this view, we can check the failband in here, and we can see the current no devices are blocked. However, and if a device attempts SIP registration too frequently, its IP may appear here in the block list. The blocking policy, such as the, let me see. We can set the failband in here. We can turn on the button to check the status, whether it is enabled. The system, and we can check the duration of the band duration and the retire times. So this mechanism is also useful as a basic security protection feature to prevent some brute force registration attacks, such as we can launch how long the IP will be blocked and how many failed registration attempts. Just like the 5. And the last is in maintenance, we can also the call trace. It's about the detailed information about the SIP message. So we can just catch about the file and you can send them to our support team for further analysis. And you need to before sending the capture file, it's best to clearly describe the task scenario, such as the calling number, call number, time of the call, and the observed issue. With this information, we can locate and diagnose the problem much more quickly. So yes, but this is the last step, and it really makes sense. And for SIP trunk configuration, the main point to pay attention is the SIP header files. In some scenarios, the SIP header address may need to be modified. Normally, with standard registration, the default settings usually work fine. However, for IMS environment, registration is changed more like a client-side domain registration. So the SIP header domain or address must be set to the server address. This is an important detail to watch carefully, and other parameters are generally straightforward and rarely cause issues if configured normally. So if the configuration is correct, move on to the checking in the network connectivity with the IMS proxy server. We can go to the maintenance diagnostics and run a ping test. If the ping fails, there is a network issue between your device and the IMS proxy that needs to be fixed. And for more complex IMS registration problems, use the call trace like this. You can go to the maintenance. It's just like the we told the before. And this process captures the registration attempt in real time, makes troubleshooting more easy. Okay, let's look at the solution to call failure. We will mainly talk about the two main issues, unable to call in IVR and call out failure. So let's solve the problem of unable to call into IVR, thus by checking the root configuration. Confirm, and we need to confirm the root source is correct and the destination is set to the IVR. Also check the priority of the routes from the same source. The IVR route is and sometimes the IVR route is overridden by a higher priority one. Next step for IVR calling problems, check the trunk stakes. So for SIP trunk, we need to make sure the SIP trunk, the IP is up and running. We can check the status. And about the actual trunk, we need also to check its status. And we need to pay attention that the actual trunk needs to config and also dial number. So don't forget to check this. And a down trunk or missing auto dial number can easily break IVR call-ins. And if the root and the trunk looks good, so just use the call trace to dig the deeper cause of that. This will help you spot any hidden signaling problems during the IVR call attempt. Now let's tackle the call out field. Start with a quick status check. Just the same with the IVR. We need to check the SIP extensions, whether it's registered successfully, and check the status of the trunk, whether it's normal. Unregistered extension or down trunk is usually why outbound calls fails. And if the status checks pass, move on to the verifying the configuration. So for local extension to SIP trunk calls, we need to confirm the SIP trunk, the IP and the ports, whether it's correct. and check the root configuration. And especially if you have multiple trunks, ensure the root is pointing out to the right destination trunk. And for internal extension to extension calls, make sure the local extension call filter is enabled. So double checking these settings can resolve most outbound call configuration issues. And another handy step for outbound call failures, we need to check the CDR records. And the CDRs are a goldmine of information. They can tell you exactly why a call fails and whether it's user by caller cancel or something else. So we can just check the failing reason in here. And if you still can't find this issue, so just use the call trends. And this will help you pinpoint the issues in the call signaling and media transmission process. So now we will move to the last chapter, the solution to call voice related issues. First, let's fix the unable to recall the issue. Start with checking the configuration. And we have the two recordings on our UC. The one is the C extensions recordings profile, and the second is the recording profile in the root. So make sure both configurations are set according to your actual needs. Just let me show you a demo. We can access into the extensions. And we can set the recording profile, the automatic or manual records. And it's also can be seen, and we also can see it in the root. The recording profile is same as with the extensions. We can set it automatic or manual. And we can also check the recording mode and the storage path in here. We can check it in the system storage. We can see the recording accounts for, and we can also resize of it. So make sure the storage location has enough disk space and the recording mode is set correctly for. And finally, let's address the call without sound issue. The call without sound. And it's just same as we checked it before. We need just to do the call trace. And in that way, we can't catch useful information in the CDR since it's a sound issue. So we can just need to do the call trace. And this will help you identify issues in media stream transmission, like codec mismatches, or network connectivity problems. Okay, that's all for today's UC training. Thank you, everyone.